This is a continuation of part B of our two rocks in space colliding problem, and just like the continuation from part A, this problem is asking whether or not the collision from part B is elastic or inelastic. And just like last time, in order to discern whether it is elastic or inelastic, we have to observe the kinetic energy. And as well, we have to delve into energy conservation. And just like we wrote the momentum conservation from part B a little bit different, we're going to write the energy conservation just a little bit different too. So we have in the initial state the kinetic energy of the first rock plus the kinetic energy of the second rock, and that is going to equal the kinetic energy of, and then we are going to do the two masses added together instead of just one mass times the final velocity squared. And just like last time, we know all of these values, so we're just going to see if by adding these two together, again, actually, this kinetic energy here from rock 2 is just going to equal 0, so we can get rid of that. So if this kinetic energy from rock 1 is going to equal the kinetic energy of the two rocks after they've attached and moved off together. So just following the same procedure, we're going to bring this down and write in all of the numbers that we know. Let's get a parenthesis. 1/2 of the first rock's mass, 3,000 kilograms, times the first rock's initial velocity of 20 meters per second squared, and then plus 0, so this is just going to be standalone, is going to equal 1/2 times the two masses added together, which in part B we just found was 4,000 kilograms. And then this is going to be times the final velocity squared, or 15 squared. So we just have to calculate these two numbers here and see if they equal each other or not. And we get that 600,000 joules is going to equal, and then we calculate all of this out, and we get 450,000 joules. So these numbers do not equal each other, and just like the first energy conservation we did, if the change in kinetic energy did not equal 0, or there was a change in kinetic energy, then it looks like our collision this time is inelastic. And that concludes our problem on the two rocks colliding in space.